morning. Today we are going to discuss about the gypsum class of monoclinic system. Till now, we have seen the isometric system, tetragonal system. Then we went for orthorhombic system, orthogonal system, and then we went for hexagonal system. And we have seen that how from one system to another system, the characteristics are changing. And now we are left with two systems, that is monoclinic and triclinic. So today we are going to discuss about the monoclinic system. So what actually monoclinic system is? Monoclinic system is uh, is classified by the three axes, among which the axis which will be nearer to the observer will be inclined. So till now we have seen isometric system, tetragonal, and orthogonal. But we have seen that all those axes were perpendicular to each other. They all those three systems were having three axes. There was the difference in their length, but the perpendicularity was maintained. But in monoclinic system, the perpendicularity has been distorted, and the axis which we refer A means which runs from observer to back. Okay, that axis will be inclined towards the observer. Okay, so it will be inclined towards you. Okay, not away from you. It will be inclined towards you. So you have to arrange the crystallographic axis in such a manner so that the inclined axis should incline towards you, and its front end will be A1 positive, whereas the rear end will be, sorry, A positive and rear end will be A negative. As the lengths of these three axes are unequal, and hence their names are A, B, and C. So A, which will run from observer to the back, will be inclined, and the B will be, which will run from right to left. The right end will be positive, whereas the left end will be negative. The C axis, which will run from top to bottom, where the top end will be positive and the rear end or the bottom end will be negative. So here we must clarify ourselves that the A axis is inclined, and hence the name is derived from it as a clinic and monoclinic. Why mono? Because mono means one. So only one axis is inclined, hence the name arrived monoclinic. Whereas the B and C axis are still in a perpendicular relationship. So the angularity between B and C is perpendicular. Only the angle between A and C is inclined. So the axis which is inclined is termed as clinoaxis. Okay, and the axis which runs from right to left is called as orthoaxis. So if you remember, in orthorhombic system, we have seen that the A-axis was named as brachyaxis, whereas the B-axis was named as macroaxis. But here the nomenclature has been changed. Here the A-axis will be called as the clinoaxis, whereas the B-axis is an orthoaxis. And why it is called as clino? Because you know that it is inclined, hence the name clino. Let us see the symmetry elements of monoclinic system. Here the one axis of symmetry is there and only one plane of symmetry is there, and of course we have one center of symmetry. The symmetry has been decreased very considerably, as we know that in isometric system there were 9, 13, and 1. In tetragonal there were 5, 5, and 1. In orthogonal we have seen that 3, 3, and 1, and we have also seen some increment in hexagonal system where the axis were 7, planes were 7 and 1. But in monoclinic system the symmetry decreased considerably, and because of which we have only one axis of symmetry, one plane of symmetry, and one center of symmetry. So there is only one axis along which if you will rotate your crystal, then your face or the referred face will repeat itself twice. So only one axis is there. Apart from that, you will Never get any kind of such axis along which if you hold the crystal, you will get the repetition. Only one axis of symmetry is there under the crystals classified under monoclinic system. Only one plane of symmetry is there. So there is only one plane along which if you will bisect or cut the crystal, you will get equal halves. So there is no other plane along which you will get the equal halves. Only one plane of symmetry is there. And of course, we have one center of symmetry, no doubt. So in axis of symmetry, this one axis of symmetry is of twofold symmetry, means you get the repetition for twice. Okay, so whatever face you will choose, it will repeat for the count of twice. It will not repeat more than that because the axis is of twofold symmetry. So this is the symmetry element of the monoclinic system, and you can see that there is a considerable decrease in these symmetry elements when compared to tetragonal, isometric, and orthogonal. And the most important thing is that here the decrease in the symmetry is attributed to the inclination of the a-axis. Okay, so because of the inclination present over in the axial system, such a decrease in the axial symmetry can be observed. Now let us see the form. So we have the well-known forms as pinacoids and domes. Okay, so as I have already told you about the pinacoids and dome in the ortho system, where the name or the nomenclature of the pinacoid or the dome is done on the basis of axis which is parallel to them. So if your face is parallel to the clinoaxis, then that will be called as a clinopinacoid. Pinacoid is made up of two faces. You must remember, you must rewind it that pinacoid is made up of two faces. It is an open form. Dome is made up of four faces. Okay, it is also an open form. But when the dome of four faces, pinacoid of two faces will combine, a closed crystal will develop. So we have only two faces in the pinacoids.
सर तुमचा आवाज नाही बरोबर येऊन राहिला.
Okay. Now is it audible? So there was a technical issue. Okay. So pinacoids consist of two faces. Okay. So the two faces will be named after its relationship with the parallel axis. Whichever axis will be parallel to it, the pinacoid will be named after it. Say, for example, if your two faces are parallel to the clino axis, then that will be called as a clinopinacoid. Okay. And if it is parallel to the ortho axis, then it will be called as a orthopinacoid. Okay. Here, in another way, you can name as front pinacoid, side pinacoid, and basal pinacoid. And you can see that in front pinacoid, you have 100 as a Miller indice. 100 means only first axis is intercepting the face, and hence it is 100. The side pinacoid, you can see here, only the side axis means the ortho axis is intercepting the side face, and hence the name is the Miller indice is 010, and ultimately the basal pinacoid also will have 001. The opposite faces will have bar on it, like 00 bar 1, 0 bar 1, 0 bar 1, 00. So you have to go through the Miller indices to understand these notations. Then we have seen the monoclinic domes and hemidomes where the four faces are there. Here again, the naming is done on the basis of axis which is parallel to them. If ortho axis is parallel to the four faces, in that case it will be called as orthodome. If the clino axis is parallel to the four faces, in that case it will be called as a clinodome. Okay, so it ultimately depends upon what axis is parallel to it, and accordingly, the intercept made by the respective crystallographic axis will decide the Miller indice. As we can see that 011, 100. Okay, so if you consider the dome 100, that means the first and the last axis is intercepting the face. Hence, there is 1 and 1 on the first and the third position. Whereas in the second position, there is 0. That means the second position is not intercepting the face. And if it is not intercepting the face, that means it is parallel to the face. So second means the ortho axis. That means 100 is representative of the orthodome. Okay. So if your first axis is parallel, that means clino axis is parallel, that means the dome is clino, that means the zero will shift on the first position. Then you can see that 0 1 1 is there. 0 1 1 means it is a clinodome, because clino is parallel, that means 0 is there. The ortho and the third B C axis will intercept, and hence 0 1 0 will be there. So it is little complex to understand, and to know much better about it, you have to go through the V's parameter, Miller and Dice, and then you will easily you will easily assimilate such kind of complex notations. Then we have monoclinic system. Okay, sorry, monoclinic prism. We have seen prisms in tetragonal, orthorhombic. Okay, now this is the monoclinic prism as well. You can see the picture over here. Again, the 1 1 0 0 0 1. You can easily understand how the axis are intercepting the respective faces. Then we can see the monoclinic hemi pyramid. Okay, these are slight complex diagrams. Better not to go there. Okay, try to focus on the pinacoid and the domes. It will be much easier to draw and much easier to write their description. So let us see some examples. Azurite and gypsum are the well-known examples. Gypsum is a normal class, as you know that gypsum shows the maximum characteristics of the monoclinic system, and hence it is a normal class. You can see the first example as azurite, it is a mineral, whereas the another one is gypsum. If you remember, the gypsum holds the second position in the Mohs scale of hardness. If you remember, the first was talc, second was gypsum, third was calcite. Okay, so gypsum holds the second position in the Mohs scale of hardness, and it belongs to the monoclinic crystal system. So let us revise our monoclinic system. Okay, so the monoclinic system consists of three axes, among which the axis which will be pointing towards the observer will be inclined towards the observer. The three axes are unequal in length, hence A, B, C is there. The angularity between B and C will be perpendicular. The A axis, which is inclined towards the observer, will be named as clino, whereas the B will be named as ortho. The front, right, and top will be positive, whereas the rest will be negative. The normal class is gypsum, because gypsum mineral shows maximum characteristic of monoclinic system. Then we have seen the symmetry elements, where we have observed considerable decrease in the symmetry elements. Only one axis of symmetry is there, which is of twofold symmetry. Twofold means the face will repeat only for twice, not more than that. And there's only one such axis system where there is only one axis over there. Then we have seen the one plane of symmetry. Only one plane is there, along which if you will cut the crystal, you will get it two equal halves. There is no another plane along which you can bisect the crystal. And of course, we have one center of symmetry in it. Then we have seen the forms, the pinacoids and the domes. Pinacoid consists of two faces. Dome consists of four faces. Their their names are done on the basis of axis which is parallel to them. If it is parallel to clino, then clino pinacoid, clinodome. And if they are parallel to the ortho, then the ortho pinacoid and orthodome. Monoclinic prism also is there, and monoclinic hemi pyramids are also there. Then we have some examples: azurite and gypsum. So thank you very much for your attention. Thank you very much.